Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Hello everyone, welcome to RoboGrace. My name is Thomas, and in this video I'm going to be showing you how you can run TinyML applications on the Wio Terminal without writing a single line of code. So I hope you watched the previous video where I covered the Wio Terminal in depth and all the features it can do. In this video I'm going to be showing you how you can run some TinyML application, do some model testing, training, and finally deploy it on the Wio Terminal. TinyML is a field of study where we can run deep, complex neural network projects on a tiny, low-power, low-cost device like the Wio Terminal. We have previously covered on how to do this with the Nano 33 BLE, and if you haven't seen that already, you can check it out on the link here. For this tutorial, we will be doing the collection, training, and programming all in one platform called the Tinkergen IDE, which I've introduced to you in the last video. So without a further ado, let's get started. To get started with the TinyML journey on our Wio Terminal, we go back to the online IDE editor that we used in the last video. Please note that I've already given a tour on how the IDE works and how you can use the IDE to develop on the Wio platform. So I highly recommend that you check out the previous video to know more about the online editor. So to get started, we will this time make an account and log in to the platform. So you log in by going to the top right corner, click on the login button. And since I already have an account, I'm just going to log in. Once I'm successfully logged in, I click on the Wio Terminal again from the main menu. You can click on model creation and you will reach this particular TinyML hub of the online platform. So in this video, I'm going to be basically training a model to recognize different motion of the Wio Terminal. So I'm going to teach it like 3 different motions, and as we will see in the video. So here we'll click on motion recognition with a built-in accelerometer. Click on it, enter the name of your project. So Wio motion tracker and click on OK. This will give you a particular code that you will need to upload to your Wio Terminal so that you can save in some data for the model to train on. So to get started, we connect the Wio Terminal using the Type-C cable, and we have to click on the upload code. Select the correct COM port and click on upload. Once the code is uploaded, now as you can see, by default there are 3 different types of training data that the IDE has already given to us. If you want to add a custom one, you can click on the plus button and add a custom one. And by default, these 3 data labels are assigned to the 3 push buttons on the top. So when I press the button A, it is going to record me doing the flip motion. When I press the button B, it's going to sample me for the wave motion, and when I press C, it's going to record the motion of the device being idle. So to start off, let's do flip. So I click on the button A, and then I just keep doing this, flip. I just keep flipping. And it says, okay, that means the data collection is done. And as you can see, 5 seconds worth of flip data has been acquired. Now, it's generally recommended that for TinyML applications or machine learning in general, we have as much as data as possible with slight variances in each of the data so that our device can reliably recognize the motion. So I'm going to record once more, flip. I'm just going to do it faster, and I'm also going to do it slower so that the model can get used to both ways of flipping. Similarly, I'm going to do the wave. So for wave, I'm going to press button B. When I press button B, it's going to expect me to wave the device. So I will do it. So I will be pressing the wave button again to ensure that I collect 10 seconds of wave data as well. Last but not the least, we also need to collect the data when the device is idle. So I keep the device on the table so that it does not move and press the button C. and just leave the device alone since it's supposed to be recording the idle position. Similarly, to collect 10 seconds worth of data, I will be doing this again. Now this is purely done in the interest of time, but I highly recommend you take at least 60 seconds or 120 seconds worth of data for each of these samples. Now once you're done, you go into the next tab called Training and Deployment. Now here you will have some configuration options to train your model. But for now, let's leave it at the default values. But later, if you want to improve your training model, you can play around with these values and get a better result out of the sensor. So for now, I will just choose a small neural network. Note that if you do click medium and large, it'll take more time for it to develop the model. So be careful about that. And now I'm going to leave number of training cycles, learning rate, and minimum confidence rate at its default. Again, later you can start playing with these values to see if you get a better model out of the collected data. Once done, I can click on Start Training. So do note that depending on your configuration, this process can wildly vary between a few minutes to multiple minutes, or maybe even half an hour to an hour. Okay, so now my training is complete. I can press this drop down button to see how the model performed. So as you can see, this model has ran the same samples that we sampled through the particular model we just trained right now, and it has given 100% accuracy. This might not reflect the real world data, but you can get an idea on the model's performance. So once you're done observing, or once you're done tweaking the parameters and getting the model that you like to, you can head to programming session and do your block-based programming as we've done in the last video. Except this time you'll have an extra tab called Use Model, where you can use the whatever model that you created with the Wio Terminal. So for now, I'm just going to make a simple system where it's going to display what it guesses. So for that, I'll go to the System tab, bring on System and Loop. Let's set the display to be in the default orientation. Let's bring the text size to be big. And let's display, and let's set the text color to black. Now in the loop function, I am going to try and guess what motion just happened. So that is this block, get data and perform prediction for the current model. Now I will go to the Display tab, go to this one and print result of the current prediction here on the print, and I will put it somewhere in between the screen. So this is right now our first code. Now I will be uploading this to the Wio Terminal. So to upload it, make sure your CodeCraft Assistant is running in the background and click on Upload. Oh, the model has not been deployed yet. Whoops, I forgot one more step in between where you have to go back to your training and deployment. And under the model training report, once you're satisfied with your model, you have to click this button called Model Deployment. This will compress the model into a small size that can be uploaded into a small low power device like the Wio Terminal. Now deployment complete. Now we'll go back to our programming session and click on Upload. You choose the correct component and click on OK. Now the first time we upload this particular code, it will take quite a while because we'll be also uploading our custom made model to the device. So just sit tight and have a coffee. So our model has finally uploaded. You just click on Roger and the program is running. So now if I do a wave motion, I expect the device to read wave. And now if you notice, the wave has been printed right above the idle. Oh, we forgot to clear the LCD screen. To do that, we go back to display, bring in the LCD clear and set screen color to, I'll make it white since our text is going to be black. So I'll make the screen white, and I'll bring the same thing also right before the device prints it on the display. So again, make the LCD screen white and click on upload and OK. Once the code is uploaded, as you can see, it gives a message that it currently reads it as an idle. Now when I do a wave motion, it should give me a wave sign. As you can see, it shows wave. Now let me do flip. And as you can see, it predicts a flip. Now you can further develop on this particular program and give it more enhanced functionality. Now let's say when it's idle, I want the background color to be red. When I wave, it changes to green, and when I flip, it starts making some sound. So let's go ahead and develop that program. So first thing, I will get rid of these things. Let's set the LCD to white in the beginning. Now I will go to control, bring the if tab, and then I will go and see that if the accelerometer prediction is flip, what do I want the system to do? So let's go to the system display tab and set screen background color. We'll set it to we'll set idle to red. Now again, similar to this one, I will drag another if block, and if the accelerometer prediction is wave, I will set the screen color to, let's say, green. Now if I'll drag another if block, and if the accelerometer prediction is flip, I will make it ring a sound. So go to the tab. If the accelerometer is flip, let's make it play some sound. I'll make it play, let's see, you can play around with the settings and get the desired sound out of it. I'm just, for the interest of time, I'm just gonna go with this one. Play beat and play, let's say, let's make it play 4 times. And after you're done, you can upload the code again and click on OK. And my upload is done. Since the device was in idle state, it changed its color to red. Now, let's see if it turns green the moment I start waving it. And as you can see, it turned green. Let's do flip and see if it plays a sound. Yep, it plays a sound. Now let's see what happens when I keep it idle. It turns back to red. Now you can play further with this, and you can further enhance and further add features based on the model that you have created on the online IDE with the Wio Terminal. So I hope you enjoyed this video. I hope you learned something, and I hope you're more confident on beginning your TinyML journey on microcontroller without being too worried about the technicalities of TinyML. In the next video, I'm going to be showing you how you can run some TinyML application around the built-in light sensor to detect gestures and motions. So until next time, stay safe and keep tinkering.